Hello students, how are you? So because of COVID-19 we are unable to conduct the classes in the traditional manner. So because of it we have started the online courses. This is the lecture 3 and the topic special functions. In the lecture 1 we have finished gamma function and its properties. In the lecture 2 beta function, its relation with the gamma function. So in this lecture 3 we are starting one of the important topics, power series solution of a second order differential equation. So this topic, power series solution, I am dividing into two parts, part 1 and part 2. So in our syllabus we need to learn Legendre polynomials, Legendre polynomials, Bessel functions and Hermite polynomials. So this 4 is our syllabus. To understand the solutions of these 4 differential equations, we need to understand what is the power series solution of a second order differential equation. So this is the basic that is required to understand the complete picture of these 4 differential equations, namely Legendre polynomials, Legendre polynomials, Hermite polynomials and Bessel functions. That wide variety of applications in the physics. This 4 is very important. Okay, so I am dividing this lecture into part 1 and part 2. Okay, let us move to the lecture on this. So in this power series solution, so the contents of this chapter will be, we define what is the meaning of power series, and then analytic function. It is very well known to you because we have already finished the complex analysis. In the complex analysis I have defined what is a complex function and CR equations and so many. So and ordinary and singular points also very well known for us. The analytic function and ordinary single points, we will take some solid examples. Then we'll start the power series solution about the ordinary point and again some solid examples. In the next lecture we'll take the power series solution about singular point, Fibonacci method, and so many types are there, type 1, type 2, type 3, type 4, that I'll take for the next lecture. So in this lecture, so we'll define what is analytic function, ordinary and singular points, and the power series solution about the ordinary point. So these are the topics for today. Okay, so the same thing I have written, the one in the stylish manner. Okay, well done students. What is the meaning of power? So it is very well known to you, power in the sense 2 power 3, 2 power 4, 2 power 5, 4 power 2, 4 power 10. So x square, x cube, x power 4, x power 10, sine square x, sine cube x. These are all the powers very well known to you, the terms. The terminology is already known to you. What is the meaning of series? Series, it is the name itself is something collection of objects, something like it placed like in the maybe in the lower standards you have learned like arithmetic progressions will be there, it is a series, and geometric progress will be there, it is a series of numbers 1 2 3 4 5. These are the series of numbers. Okay, so power series, so that means the terms will have the powers here, something like x square plus x cube plus x power 4 plus x power 5 plus x power 6. It is a series. Something like sine square x plus sine cube x plus sine 4x plus and so on. It is a series. So okay, power series. So the word power itself is very well known to you, and also series also very well known to you. The power series we see. So an infinite series of the form, it is clearly mentioned here, of the form you see here. Of the form, just a second. So an infinite series of the form, it is I have mentioned here, infinite series. Series can be finite or it can be infinite. It will be powers. It is something like C0 plus C0 is a constant, and then C1 x minus x0 plus C2 x minus x0 whole square and so on is called a power series in x minus x0. So okay, fine. So a power series in x can be written as, it is power series in x minus x0. Suppose in place of x0 if I substitute will be 0. So if I place x0 is equal to 0 in the above, then it will become a power series in X an infinite series. So that means the terms will be keep on going. So we'll see whether it is a converging or otherwise diverging. Okay. And there are very well known example for as a power series expansion containing infinite terms is the exponential function e power x. So this function e power x can be written as, of course, this is the summation symbol, sigma goes from n equal to 0 to infinity x power n by n factorial. So this can be written as, first term is 1, so that means c naught will be 1, second term will be c1x, so again c1 will be here 1 only, then it will be c2x square, then a c2 term will be 1 by 2 factorial, then c3x cube, that is 1 by 3 factorial. It is a power series in x, so that means each term series has containing power. So you may say, so 1 is here, then where is the power here? So 1 is here means I can write 1 will be as x power 0, the power is 0, x power 0 is the 1, then x power 1 is here, then x power 2 is here, then x power 3 is here. So okay. So like in this manner, so power series, that means a function can be represented in terms of the power series. Okay, fine. I hope it is clear. So the power series, I said already, whether it is converging or otherwise diverging. So all the power series here I consider will be the converging. Converging means, so that like something like we can say a light rays are coming and converging at a particular point. Suppose if I take a convex lens, so if light falls on it, all the light will converge at a particular point. Converge means all our things are coming to a point. So the power series converges absolutely for modulus x is less than r. Then what is r will be here? We call it the radius of convergence that I already explained in the complex analysis. So r will be here, it is limit n tends to infinity modulus of coefficient of x power n term divided by coefficient of x power n plus 1 term. So Cn is the coefficient of x power n. Cn will be the coefficient of x power n. This is the term where is x power n term. So then what about n plus 1? So n plus 1 will be the coefficient of x power n plus 1. This will be the x power n plus 1 I need to consider. It is x power n plus 1th term coefficient. And this will be the x power n in the sequence. If I divide these two, so that r will be, that is limit n tends, that must be less than r provided the limit exists. Of course limit will be exist. Okay, then what is this r is called? R is said to be the radius of convergence of power series in the interval minus r to r. That means something like maybe something r can be some, say for example 10, it will be from minus 10 to plus 10. Okay, even sometimes it is an infinity also, so it is something like minus infinity to plus infinity, minus infinity to plus infinity. The same thing in case of a complex analysis, so means we have used the term into the disk of convergence. It is something like a space will be occupied here, then r will be called as a radius of convergence. But in case of real analysis, there is no type of like this, it is only a line, straight line, the radius of convergence. Okay, fine. That means we understood what is the power series, what is the meaning of converging. Converging means the series will be, so the values in the series will be keep on decreasing. Say first term will be, say for example 100, the next term will be 99, the next term will be 98, 94, like that the series will be tried to converging and finally maybe reaching to 0. So we call it, this type of sequences are the converging. What is the meaning of diverging? Let's say sequence starts from something like 1, then it will become 2, 1, 3, 4, 5, 6, 7. That means it is diverging, it goes to infinity. So that type of series are known as the diverging series. Okay, fine. So remember the following results. A power series represents a continuous function within the interval of convergence. So you know in the lower standard level what is the meaning of continuity of a function and how to check it. So I will not explain again here. So the function will be smooth everywhere. That means a power series represents a continuous function within its interval of convergence. Within that interval of convergence, within the radius of convergence, the function will be continuous. And also one more thing, in the power series, differentiated term wise, even integrated also. So what I have written here, each and every term will be integrated. So the same example you take, that is e power x. So if I take the same example, it will be e power x. If I say it will be integrated, can I integrate each and every term here? Definitely you can integrate each and every term here. So we can integrate each and every term here. So I can integrate this term, e power x integration. So 1 I can integrate, x I can integrate, x square I can integrate, x cube I can integrate. In a similar manner, even I can differentiate. What is the d by dx of e power x. So I can differentiate the first term, differentiate the second term, differentiate the third term, like that. So what I am saying, so that means we can differentiate each and every term. A power series can be differentiated term wise within the interval of convergence. That means a power series, it is a continuous function and also differentiated each and every term. So remember these results, it will be useful for us for further understanding of this topic. Okay, now let us move to the very well known thing for us, analytic function, that we learned in the complex analysis. Analytic function. So what is the definition of analytic function? We saw like, so the function which satisfies the CR equations is known as the analytic function, or otherwise where the different f dash z exists everywhere. The same thing will be written here. So this is some modified form. A function f of x defined on an interval containing the point x is equal to x naught is called analytic. When we call that function will be analytic. This function is called analytic at x naught if its Taylor series exists. So that means Taylor series will be possible. That means expansion of that will be possible. Taylor series. That will be sigma n equal to 0 to infinity. The function, what is the meaning of here? Bracket, and I have written n here. That bracket and n means differentiation. Like if it is f power 1, if it is f power 1, I need to differentiate one time. If it is f power 2, let's say it will be f power 2, we need to differentiate twice. If it is f power 3, we need to differentiate thrice. So and at x naught divided by n factorial x minus x naught. That means when we say that a function will be a function f of x is defined interval is an analytic at that point if Taylor series expansion is possible. That means that series will be possible. If the series is possible, the Taylor series, we say that the function is analytic at that particular point, and of course exists and converges to f of x for all x in the interval converging series. That means that must be a converging series. If Taylor series exists, that obviously it will be a converging series. Okay, fine. So that means very clear here, analytic function. Even I take some examples to understand more clearly. So straightforward, all polynomial functions e power x, sin x, cos x, sin hx and cos hx are analytic everywhere. So within their domain, within the radius of convergence, they are like in the interval from minus infinity to plus infinity, everywhere in the sense from minus infinity to plus infinity, they are analytic. Some x equal to 0, they are analytic. X equal to 10, they are analytic. X equal to pi, they are analytic. So everywhere they are analytic. So a rational function is analytic except at those values of x at which its denominator is 0. So be careful here, this is the important term. What I am saying here, if rational function in the sense it will be in the form of p upon q, that will be in the form of p upon q, p by q. Suppose a function will be in the form of p of x by q of x, the function will be like this, then it will be analytic. At which point it will be analytic means, I have written very clearly here what I have written. A rational function is analytic except at those values of x at which the denominator will become 0. First of all, determine the denominator equal to 0. Put the denominator equal to 0. Excluding these points, that function will be analytic everywhere. What I am saying, exclude the points at which denominator will become 0. Logically, you think of if denominator will become 0, then what you will get? Something by 0 will be infinity. So that is meaningless. So that means we need to consider the values at which the denominator will not become 0. So will not become 0. That point we will consider. Then at that particular point, excluding that point where it will become infinity, rest of the points will be considered as the function is analytic. Okay, remember this point, we keep on using its application. Okay, let us take some example. What I have written in the example, the rational function defined by, so rational function, how I defined here, it is a numerator is x and the denominator is x square minus 10. So numerator means above term, denominator means below term. So that means the function is written here x upon x square minus 3x plus 2. It is x divided by x square. So x will be the numerator above term, denominator means below term, that will be x square minus 3x. It is x square minus 3x plus 2. So now where it will be analytic, I have written here clearly mentioned, it will be analytic everywhere except the denominator will become 0. So the denominator, the point at which the denominator is non-zero. So that means if denominator will become 0, then everything, if it is become 0, x by 0, something meaningless. So that's why first of all determine the places at which the denominator will not be 0. So that means see here, it's analytic everywhere except at x equal to 1 and 2. So 1 and 2 are the factors of this quadrant. So this quadratic expression will have the roots at x equal to 1 and x equal to 2. That means if I substitute x equal to 1, then what will happen? X equal to 1 square minus 3 plus 2. So that means 1 minus 3 is minus 2 plus 2 0. That means x square minus 3x plus 2 will become 0 at 1 and 2. When I substitute x equal to 1, that will become 0. When I substitute x equal to 2, that will become 0. That means the denominator will become 0 at 2 points. So x equal to 1 and x is equal to 2. Now what I said here, this will be analytic except these 2 points. So that means I have a real numbers which starts from minus infinity and ends at plus infinity. Now we need to remove 2 points. What are those 2 points? X equal to 1 and x is equal to 2. If you remove these 2 points, then it will be analytic. So we say the function f of x equal to x upon x square minus 3x plus 2 will be analytic everywhere except at the 2 points 1 and 2. Okay, I hope it is clear what is the meaning of that point. Okay, next I will define what is the meaning of ordinary and singular points of a given differential equation. So I am taking the second order differential equation. So the second order differential equation will be looking like in this form. It is y double dash p of x y dash plus q of x into y. What is the meaning of y double dash here? It is very well known. Y double dash means 2 times differentiation. Y double dash will be the 2 times differentiation. That means d square y by dx square. 2 times differentiation will give the y double dash. What is the meaning of y dash? So y dash means it is simply 1 time differentiation. Y dash will be is equal to dy by dx. dy by dx. So it is a 1 time differentiation, dy by dx. So remember, so what is the meaning of 2 time differentiation, 1 time differentiation here? Y double dash, it is very well known to you. Even in the lower standard also you might have used the same thing. Dy by dx means y dash. So d square y by dx square means y double dash. Okay, fine. So what is the meaning of an ordinary point and a singular point? So there are the 2 functions. P of x is one function and q of x is one function. P of x is the coefficient of the first derivative term y dash and q of x is the coefficient of the term y in the given second order differential equation. So now I am defining here a point x is equal to x naught is called an ordinary point of this differential equation if both the functions p of x and q of x are analytic at x is equal to x naught. They must be analytic at x is equal to x naught. Then we say that p of x and q of x are this ordinary point. So that means we say that x equal to x naught is the ordinary point if p of x and q of x are analytic functions. So I already explained what is the meaning of analytic function. Okay, I hope it is clear. Remember, ordinary point of a differential equation means the 2 functions p of x and q of x. What are the p of x? Where the p of x will exist? Remember, you need to make this term will be 1. This coefficient will be 1. Then the coefficient of first derivative term, this will become the p of x. Then where is the q of x will be? Y, the coefficient of y. This will be the second q of x, the coefficient of y. So now consider p of x and q of x. So let's say they are analytic at x equal to x naught or not. If analytic, remember both p of x as well as q of x, both must be analytic. So sometimes what happens, P of x will be analytic but Q of x is not, or otherwise P of x is not analytic but Q of x will be analytic. That case we say that key x equal to x naught is not, it is not an ordinary point. So ordinary point means both must be analytic at the given point x is equal to x naught. Suppose if x equal to x naught is an ordinary point, suppose it is not an ordinary point, so then automatically it will become the singular point. If the point x is equal to x naught is not an ordinary point of the differential equation, then it is called the singular point of the differential equation. Okay, it is very clear. So this is very important. We need to check first of all what is the ordinary point and ordinary point or otherwise singular point. So of a given differential equation, so whenever you take the second order differential equation, you write it will be in the standard form like this. You must write in this form. So how this term will be looking like here? So here it is very clearly mentioned. You make first this coefficient will be 1. I am making this coefficient will be 1. You make this coefficient will be 1. Then afterward you make this coefficient of y dash. So this is the second term. This will become the p of x. Then coefficient of y, q of x. This will become this function will become the q of x. Now check at the given point x equal to x naught whether they are analytic or not. If they are analytic, then it is called x equal to x naught is called ordinary point, otherwise it is a singular point. I hope it is clear. I will not stress further here. So again, singular point will be of two types, a regular singular point and irregular singular point. So these terms are familiar guys to you, already I mentioned in the complex analysis. So singular point will have the two types, a regular singular point and irregular singular point. Then what is the definition of a regular singular point? So is called the regular singular point. That means I am taking x equal to x naught, finally decided is a singular point. Now decide whether it is regular or irregular. For that purpose again I need to take the two things. So what are the two things? X minus x naught into p of x. Remember, p of x multiplied with x minus x naught. Then q of x multiplied with x minus x naught whole square. Q of x multiplied with x minus x naught whole square are analytic at x equal to x naught. So if they are analytic at x is equal to x naught, so which are analytic? The first one, x minus x naught multiplied by p of x, and x minus x naught multiplied x minus x naught square multiplied by q of x. That means x square side. If these two are, that means we are making the two more new functions. One is x minus x naught into p of x, another one is x minus x naught whole square into q of x. If these two are analytic at x equal to x naught, then it is known as the regular singular point, otherwise irregular singular point. Remember again, both must be analytic. This also analytic and this also analytic. So both must be analytic. Suppose one is analytic, say for example this is analytic but this is not analytic, then we say that it is a irregular singular point. What I mentioned, both must be analytic. So x minus x naught into p of x, x minus x naught whole square into q of x, both must be analytic at x equal to x naught, then only it is a regular, otherwise it is irregular. So many cases will happen, this one function will become analytic, so this will become analytic and this may not. So then what is that point is called irregular. It may happen like this will be analytic and this can't be analytic. Then what is that point? Irregular point. Irregular point. Okay. So obviously the case will become this into this, then obviously it is a regular point. Then another case, this one, obviously this will become the regular singular point. The only one possibility where it will become the regular singular point means both are analytic. Okay, I hope it is clear to guys. Then I'll move to the next. So now I am taking some solid examples to understand what is the meaning of ordinary and singular point. So whether it is a regular singular point or a irregular singular point, whether the given differential equation has analytic, that means whether it is analytic, how to determine a function will be analytic or not, how to determine the ordinary and singular point, how to determine the regular and irregular singular point. So let's say first example will give, determine whether x equal to 0 is an ordinary point or a regular singular point of the differential equation given by x square. So why it is given, it is 2x square second derivative y double dash, that is this square over dx square plus 7x into x plus 1 divided by dx, that is y dash, minus 3y. This is the given differential equation. So what I said, whenever they have given the differential equation, you first put in the form of standard differential equation. How the standard differential equation will look like? The standard differential equation will look like this. This is the standard differential equation. The first y double dash, the coefficient must make 1, here must be 1. So now I'll do that thing here. So what it is here, 2x square will be extra here. Okay, now what I need to do, this 2x square is there. Now I divide the entire equation with 2x square. That means here 2x square by 2x square will become 1. Then it is 7x by x plus 1, 7x by x plus 1 divided by 2x square. That means here it is 7x is there, here 2x square is there. I am cancelling x and 2x. I hope it is clear. Then minus 3 divided by 2x square. Okay, here it is x square is there, guys, and here it is 7x is also there. That x and this x square is cancelled. That's why I have left with 2x. So now I put in the form of standard equation. That means y double dash plus y dash with coefficient will be 7 into x plus 1 by 2x. Then plus y with the coefficient will be minus 3 by 2x square. That means this will be in this form or not? Clear, it will be in this form. Y double dash term. Yes, y double dash. Then y dash term. This is the y dash term. This is the y dash term. Then this will be the y term. Then what is required for me? The coefficients are required. Then what is the coefficient will be here? The coefficient will be p of x will be here. Then what is the same p of x will be here? This is 7 into x plus 1 divided by 2x. Then it will be q of x. Then what is that will be here? Remember guys, along with minus sign. Minus 3 by 2x square will be the q of x. Okay. So by comparing with the standard equation, I have determined what is the p of x and what is the q of x. Now I need to check whether it is an ordinary point or otherwise singular point. I said already. So how to check whether it is ordinary point or ordinary point or singular point? So p of x and q of x must be analytic at x is equal to 0. We have p of x and q of x. Since both p of x and q of x are defined at x equal to 0. X equal to 0, defined or undefined? Definitely it is 7 into x plus 1 by 2x is there. In the denominator 2x is there. If I substitute x equal to 0, then what will become something by 0? Infinity. Infinity. So then I say they are undefined. They are not defined. Even q of x also minus 3 by 2x square. If I substitute 0 here, minus 3 by 0, it will become infinity. So they are not analytic. So that means if it is a rational function, I need to search for a point at which denominator will not be 0. If denominator will become 0, then I said they are not analytic functions. So that means in the denominator here 2x will become 0 at x equal to 0. Then entire thing will become infinite. Then 2x square will become 0 at x equal to 0. Then entire thing will become infinite. So both phi of x and q of x are undefined at x equal to 0. So they are not analytic at x equal to 0. Remember. So not analytic means it is not an ordinary point. Not an ordinary point. If it is not an ordinary point, definitely what it is called, guys? It is called a singular point. That means for the given differential equation, x equal to 0 is a singular point. Now move to whether two types of singular points will exist, whether it is regular or irregular singular point. So what is the condition for regular and irregular singular points? Just now I explained to you the conditions. Once again you see here, x minus x naught multiplied by p of x. In our case, x naught will be the 0. X naught will be the 0. Now they are analytic or not, we need to check. Okay, more than x minus x naught into p of x. So x minus x naught place I am putting 0, p of x. So p of x will be 7 into x plus 1 by 2x. So that means already x is there, with this x cancels. That means I have here 7 divided by 7 into x plus 1 divided by 2x. It is p of x. But what I need to write? X minus 0. X minus 0, that is x. So now this x and this x will cancel. What I have? 7 into x plus 1 by 2. And what is q of x? X minus 0 whole square into q of x. So that means what I have? So q of x will be minus 3 upon 2x square. It will be minus 3 upon 2x square. Then what is there here? X square, x minus 0 whole square, x square into x square is there. So that means this x square and this x square will cancel. Then what I left will be minus 3 by 2. So that means what I can clear here finally, I have the term will be of, this is of 7 into x plus by 2. The term will be 7 into x plus 1 by 2 is the one term. The another term will be minus 3 by 2. What I say guys, the term 7 into x plus 1 by 2 and another will be minus 3 by 2. Both are defined at x is equal to 0. So that means now the functions will be analytic. So that means they are called regular singular point. Now they are analytic. Nowhere they will become nowhere they are becoming infinity. So that means, so the denominator is simply numbers 2 and here also 2. There is no function is involved. That means no need to substitute x equal to 0. They are they are defined. So that's why it is a regular singular point. They are analytic. I hope it is clear. This problem clearly explains how to find out whether the given point will be a ordinary or singular. If it is a singular point, then how to define whether it, how to calculate, how to find whether it is a irregular singular point or otherwise regular singular point. I hope guys it is clear. So whatever the concepts I have explained, this example will clear everything. I hope guys it is clear to everyone, and how to determine the given differential equation. So for a given differential equation, whether the given point x equal to x naught is an ordinary point or singular point, or whether it is a regular singular point or otherwise regular singular point. We'll move to another example. In this example, what I said here, so that x equal to 0 and x equal to minus 1 are singular points of the differential equation, where the first is irregular and other is a regular. It is somewhat more complicated and more clear. See here what it is mentioned in this problem. There are 2 points are given. One will be x is equal to 0 is given, another one will be x equal to minus 1 is given. We need to show that both are singular points of the given differential equation. If it is a singular, then one point I need to show that it is irregular. The first one will be the irregular, then second one I need to show that it will be the regular. So x equal to 0 is irregular, x equal to minus 1 is regular. This one is the task. So as usual, first one need to write in the form of standard equation. The standard equation will looks like this. So that means the coefficient of second derivative here will be this term. This is the coefficient will be x square multiplied with x plus 1 whole square. Now you need to make it 1. That means you divide the entire differential equation with that term. So this will become 1. Then already here it is x square minus 1 y dash divided by x square into x plus 1 is here. So x square into x plus 1 whole square. Then one thing I have mentioned guys here, you observe very clearly what is here, x square minus 1 is there. I have written this term as like this. So I'll explain here. So x square minus 1 can be written as x square minus 1 square. So x square minus 1 square is again 1. Now compare this equation with a square minus b square. A square minus b square can be written as a plus b into minus b. A plus b is x plus 1 into a minus b is x minus 1. So I hope it is very clear. That means what I have written here, instead of writing x square minus 1, I wrote directly x plus 1 into x minus 1 in this term. So out of x plus 1 and x minus 1, as I am dividing with x square multiplied by x plus 1 whole square, so that means x plus 1 term is cancelled, then x minus 1 term only remaining. Okay, I hope it is clear. Then go to the next term, that is 2 divided by x square into x plus 1 whole square into y is equal to 0. Okay, so now I have compared with the standard equation, because I need to determine what is p of x and what is q of x. So that definitely then p of x will be, after making that coefficient is 1, I have made this coefficient will be 1, then p of x will be this entire thing. Then what is the q of x will be? Then q of x will be this entire thing. Q of x will be this entire thing. I hope it is clear. Now let us take p of x and q of x. Then next procedure, you know whether it is a regular point or otherwise it is a singular point. So they have given 2 points, so x equal to 0 and x is equal to minus 1. So move to the next. So p of x will be x minus 1 divided by x square into x plus 1, then q of x will be 2 divided by x square into x plus 1 whole square. So very clearly in the denominator, these are the rational functions. You observe the down term, that is denominator term, below that fraction term. So it is x square, x plus 1 here, x square into x plus 1 whole square. So let us check at what points they will become 0. So at what points they will become 0. So these are when it will become 0. Now already they have given 2 points, x equal to 0 and minus 1. Check x equal to 0. Obviously it will become 0. Here also x equal to 0 becomes 0. So denominator becomes 0. Something by d0 is it will become infinite. So undefined. So that means they are not analytic at x equal to 0. Now put x equal to minus 1. So put x equal to minus 1 here. This is minus 1, this is plus 1 will become 0. Here also this is minus 1, this is plus 1 will become 0. So that means x equal to minus 1 also making the denominator 0. That means the term p of x and q of x will be undefined. So that means for x equal to 0 and for x equal to minus 1, p of x and q of x are undefined. That means they are not analytic at these points. Not analytic means singular points. Okay, clear. Now next go to whether they are regular singular points or irregular single points. For that purpose one need to take x minus x naught into p of x, x minus x naught whole square q of x. Okay, first x minus x naught, that is 0. I am checking first 0. So first we are checking for the 0. So I am checking first for 0. X equal to 0 will check. So let us check for x equal to 0 first. This is x equal to 0. So x minus x naught 0 into p of x. P of x will be here x minus 1 divided by x square into x plus 1. But x and x will cancel. Now clearly substitute x equal to 0. It will become 0. So it will become 0 in the sense something by 0 infinity. It is undefined. It is undefined means they are not analytic. Once they are not analytic, what we call it as a irregular. You don't need to check for q of x. Automatically one becomes undefined, then it is irregular. Then even check another one also. X minus x naught whole square, that is 0 square into q of x. So this will be x square multiplied by q of x. So x square in the term here also x square is there in the q of x, and with this x square also will multiply and cancel each other. Now you put here x equal to 0. So this term is non-zero. 0 plus 1 whole square, it is 1. So 2 by 1 is 2. They are not undefined. They are not become to infinity. They are finite values 2. So that means it is finite. But what I said, both the terms x minus x naught into p of x, another term x minus x naught whole square q of x, both must be defined. They must be finite values. Then only it will become the analytic. So if any one will become undefined, that means denominator term is become 0, then they are not analytic. That means here the first term is obviously undefined. That's why no need to bother about the second term. It will be irregular. Okay, so the given point x equal to 0 will become finally irregular singular point. Next, so the x equal to 0 is over. Then go to the x is equal to 1. So the next I am going for the x is equal to 1. So this I already checked for x equal to 0. Now this will be the x is equal to 1. I am taking x is equal to minus 1. Now what is that? X minus x naught. X naught place, you need to substitute minus 1. Minus 1 will become plus 1. X plus 1 into p of x. That means x minus 1 divided by x square into x plus 1. But this x plus 1 and this x plus 1 will cancel. So here also x plus 1 is there. Multiplication also x plus 1 will be cancelled. Then what is remaining? X minus 1 by x square. Now you put minus 1 here. What is minus 1 whole square? 1. Then you put minus 1 here also. That is minus 1 minus 1. Minus 2 by 1. Minus 2 by 1 is minus 2. It is a finite value. Then go to the next one. What is that? X minus x naught whole square. X naught place is minus 1 x square q of x. That is equal to 2 divided by x square into x plus 1 whole square. But that x plus 1 whole square, that x plus 1 whole square cancel. Then what is remaining? 2 by x square. Then substitute x equal to minus 1 here. 2 by minus 1 whole square, that is 2 by 1, that is 2. Here the first term and second term both will be coming as the finite values. They are not going to infinite. That means finite in the sense they are regular singular point. That means x equal to minus 1 will become the regular singular point of the given differential equation. Okay, I hope it is very clear. Then how to determine whether the given, for a given differential equation, the point x is equal to x naught is a irregular or regular singular point. So next move to the power series solution. Next topic it will be power series solution about the ordinary point x is equal to x naught. Now remember, I am taking the power series solution of ordinary point of the differential equation. I am doing the power series expansion about the ordinary point. It is not the singular point. That singular point will be taken for the next class, that is the Fibonacci method will be discussed. Now I am taking the ordinary point. So let the standard form of the differential equation. This will be the standard form of differential equation. So now I have taken already x equal to x minus, and it is the ordinary differential equation. This ordinary point of the given differential equation. Obviously it is the second order. I have the two non-trivial linearly independent solutions. That means two solutions will be there. So I need to calculate the solutions of this differential equation. Means I need to find the y, which y will this satisfy here. There exist two y's, y1 and y2, both are different. So second order differential equation. So we have the two solutions for it, y1 and y2, and both I need to determine here. So then what I said here, I am taking the power series. Then power series I already explained, c1 plus c0 plus c1 x power 1 plus c2 x power 2, c3 x power 3, and so on like this. So this is the solution. I am assuming the solution of this differential equation will be in this form. It is the power series solution. That means y is equal to some constant multiplied by x square, x cube, x power, like that. So okay, so I am taking this differential equation, and this is the solution of that differential equation. So I want to determine what is c1 here, what is c2 here, what is c3 here. Then only the problem will be finished. Okay. Well students, so far we have finished what is a power series, what is the analytic function, what is ordinary point and singular point of a analytic function, or otherwise given differential equation, sorry. So what is the ordinary and singular point of a given differential second order differential equation, and how to determine it. We have seen some examples also. Now we will move to the power series solution about the ordinary point x equal to x naught. So power series solution will be two things, one about ordinary point, another one about singular point. So in this class, in this video, I said already we will be discussing power series solution about ordinary point x equal to x naught. In the next class we will discuss about the singular point, that Fibonacci method we will discuss. Okay, fine. So as usual, we will take the second order differential equation in the general form. So how the general form of second order differential equation will look like? The general form of second order differential equation will look like in this form. So this is very well known to you. Then what is the ordinary point? We call x equal to x naught is the ordinary point. Then obviously it is the second order differential equation. It will have the two linearly independent solutions. That means there will be two functions, let's say y1 and y2 will be the independent solutions of this differential equation. Remember what I am saying, it is linearly independent solutions. Okay, y1 is entirely different from y2. We cannot derive y2 from y1, vice versa. Okay, so I am assuming the solution will be in the form of power series. I said already, power series means c0 plus c1x, c2x square, c3x cube, and so on. If it is about x naught, c0 plus c1 into x minus x naught plus c2 into x minus x naught whole square plus c3. That I already said to you. So that means I am assuming the solution will be in this form. So y is equal to, so sigma summation is going from n equal to 0 to infinity, cn x minus x naught whole power n. So as this is the solution, I said already, this is the solution of the given differential equation. So that means this y value I can substitute in the given differential equation. So I can substitute in this differential equation. So if it is, obviously it will satisfy, means left hand side is equal to right hand side. If I substitute y value here and I'll equate 0, then I will determine what is c1, c2, c3, c4. So guys, remember what we are doing here. We are saying that here the solution of this differential equation will be in what form? It will be in the form of series. If it is a series, obviously a function of x. So there will be unknown constants like c0, c1, c2, c3, c4, c5. So our aim is here we are assuming solution will be in this form, and we need to finally decide what is C0 value, what is C1 value, what is C2 value. For that purpose what I will do, as it is a solution, back substitute into the given differential equation and apply necessary boundary conditions if it is there. So I'll substitute in the given differential equation. So I'll substitute this will be in the given differential equation. For that purpose what I need, y double dash, that means second derivative of this one, y dash first derivative of this one. So finally what I am doing here, so we need to determine the differentiation of this with respect to x 2 times. dy by dx also we required, d square y by dx square also required. So then clearly observe here what is this function will be here. I said we already assumed in a power series each and every term will be differentiable. We can differentiate each and every value. So that means here it is x power n is there, something like x power 0, x power 1, x power 2, x power 3, x power 4. Then what is the formula for d by dx of x power n? So dx by dx of x power n formula, that is very well known to you. This will be n into x power n minus 1. So n into x power n minus 1. If it is x square, that will be 2x. If it is x cube, 3x square, like that. So okay, this is very known to you. So that means I want the double derivative and the single derivative. Let's see here, already done. So first time differentiation will give n into x power n minus 1. Second time differentiation will give, then again differentiation of this n, that is here it is n minus 1. n into x power n minus 1. Already minus 1 is there, so it will become minus 2. So finally I got what is the first derivative of y and what is the second derivative of y. So after knowing that, what I'll do, I'll substitute this y dash and y double dash in the differential equation. So I'll substitute, putting all these values y dash and y double dash in the equation 1. What is the equation 1? Obviously this is the differential equation. So this is the 1. So I'll substitute these values. Then after substituting, I'll get in this form something like constant term, then x power 0, constant term is x power 0, then x power 1, then x square, then x cube, then x power 4, and so on will be equal to 0. This type of equation I'll get. See, left hand side entire thing will be is equal to 0. So and everything will be independent of each other. That means the coefficients A0 will be 0, A1 will be 0, A2 will be 0, A3 will be 0, where the coefficients A0, A1, A2 are now some functions of the coefficient C1, C2. So A0, inside the A0, C0 will be there, C1 will be there, C2 is there, C3. Similarly A1 is a function of C0, C1, C2. Similarly A2 is again a function of C0, C1. Now we equate this all. A0 will be 0, A1 will be 0, A2 will be 0, A3 will be 0, A4 and so on. Then finally we will determine what is the value of C0, what is the value of C1, what is the value of C2. Once I know C1, C2, C3 values, what I will do, I will substitute here. So once I will substitute here, I will get the solution. Okay, you understood what we are doing here. Now let's proceed. So I said already, all will be 0. Since it is an identity, all must be equal to 0. Then solve for it. Okay. So let us take some examples. So then you will understood then how to approach all these things. So I am taking the, see, before going to this, I'll say it again. What we need to do here. So given differential equation, write in the standard form. After writing the standard form, assume the power series solution. So after assuming the power series solution, what we need to do? So y is equal to summation sigma n equal to 0 n cn into x minus x0 whole power n. That is the solution. Then differentiate once, differentiate twice. You will get y dash and y double dash. Then what you do? You back substitute in the given differential equation. So then what you do? You arrange all the terms. First will be constant terms, x power 0 term, then x power 1 term, x power 2 term, x power 3 term, and so on like that. So after arranging like that, equate each and every coefficient of x will be 0. Then solve for C1, C2, C3, C4. I hope it is clear. The same technique I'll adopt here. So let us go for the first question in this here. Find the power series solution of the given differential equation. It will be in the form of x square y double dash xy dash minus xy equal to 0 in powers of x, that is about x equal to 0. So that means they have already mentioned the point about which we need to determine the solution. That means here it will be x equal to 0 must be an ordinary point. That means p of x and q of x will be defined at x equal to 0, they are analytic. Defined and analytic. So given differential equation will be in this form. I said already, you write in the form of standard differential equation. In the standard differential equation, the coefficient of y double derivative will become 1 here. Then this will be p of x and this will be q of x. So for that purpose, what we do, to make y double dash coefficient will be 1, divide this x square plus 1. So x square plus 1 divide x square plus 1 divided by x square plus 1, cancel, it will be 1. Then x in the numerator here, then x square plus 1 in the denominator. Similarly, x in the numerator here, x square plus 1 here. So very clearly observe what is the value of, so p of x here, this is the p of x. What is the q of x here, including minus n? These are the, I got finally what is the p of x and the q of x values. So write the p of x and q of x values. So I have written p of x, x divided by x square plus 1. I have written q of x, x square plus 1. So I need about x equal to 0. So this is the x equal to 0. Cross check, it is a rational function. In the denominator x square plus 1 is there. Will it become 0? No. Because x square plus 1, if I put 0, 0 plus 1 is 1. So okay, in the denominator we are not getting 0. We are not getting 0 means p of x will not become infinity. Similarly here x square plus 1. Okay, no problem. That means p of x and q of x both are analytic at x equal to 0. It is an arbitrary point. Then we can take the solution. So what is the formula for the solution? Y is equal to sigma n equal to 0 to infinity Cn x minus x naught whole power n. But luckily here x naught will be 0. Then I have Cn x power n. So Cn x power n means first term will be 0. C0 x power 0. Here x power 0 will be there. That x power 0, you know, it is already 1. So then what I have, C1 x power 1, C2 x2, C3 x3, C4 x4 and so on like that. Then what I said, determine the first derivative of it. This is the first derivative of it. Then you determine the second derivative of it, second derivative. So you remember this mug up, this always first derivative and second derivative will be this only x power n formula, n into x power n minus 1. Okay. So after knowing this, what I said, you substitute this y dash and y double dash in the differential equation, in the given differential equation, in order to determine C0, C1, C2, C3 values. That's what I am doing now. I'll substitute, this one will be in substituting. So substituting, what is the first term in the differential equation? If you see what is the first term in the differential equation, it is x square plus 1 y double dash. So it is x square plus 1 y double dash. See here, x square plus 1, here it is x square plus 1, y double dash, 2 times derivative. What is the 2 time derivative? Here it will be the 2 time derivative, here this is the 2 time derivative. Okay, that I am substituting here. So after substitution, what I will get here is n equal to 2 to infinity, n and n minus 1. So definitely here n minus 2 is there. From where n starts? N starts from 2. Then what is the second term will be? X into y dash. In the differential equation, x into y dash. X is there, y dash. So you see here x into y dash is the second term. Okay, fine. Then what we need to, x into y dash will say, this is the y dash. Substitute this y dash there. So if I substitute y dash will be there, x into sigma n equal to 1 to infinity, because here n x power n minus 1 is there, n starts from 1 to infinity. Then last term will be the y term. What is the y term in the given? Minus xy. So you substitute the y value. So y value is this only, minus x y. So I hope clear, minus x into sigma n equal to 0. So I substituted in this step. Then afterwards what we will do, I will simplify. So how to simplify? First write the constant term, then write the x power 1 term, then write the x power 2 term, then write the x power 3 term and so on. First I will collect. See here, sigma is going from n equal to infinity, and here it is going from n equal to 1 to infinity. So make all the summations will be uniform. Suppose here it is going from n 2 to infinity now. You make here also 2 to infinity. You make here also 2 to infinity. N equal to 1 to infinity. First I will substitute n 1. So what I am doing here, nothing, I just multiplied here. If I just multiply x square multiplied by n into n minus 1. But here is x square is there, but here it is x power n minus 2 is there. Then powers will be added. 2 plus n minus 2, I have only x power n. Then okay, then it will be plus, then it will be plus, then multiply with 1. This entire thing will be multiplied. 1 into something is again the sigma n equal to n into n minus 1, Cn x power n minus 2. Then as usual, the next term will be, what is the next term will be? Plus term will be there. This is the plus term, sigma n equal to x power 1 will be here, x power n minus 1. Then automatically 1 plus n minus 1 is x power n into Cn. Then it will be minus sign will be there. Then minus sign, Then again here what is there? X power 1 is there. Then what is here? X power n is there. It will become x power n plus 1. Be careful, and you just, it is a self explanation to you. If you see, you will understand. Okay. So then what I have? Then of course it will be the plus. Remember here it will be the plus symbol, and of course here it will be the minus symbol. Then of course it will be the plus symbol here. Okay. Then after, then what we need to do? So n equal to 2, okay, no problem. N equal to 2, no problem. But n equal to 1 is here. What do? You just expand. So it is expand. N equal to 1. That means first I take n equal to 1, you substitute. Then n equal to 2, no need to substitute. We take all n equal to 2's together. Okay. See guys, that's what I am doing here. This term will be as it is, n equal to 2. Then but it will be from where it is starting? It is starting from n equal to 2. So n equal to infinity. It will be n into n minus 1 cn into x power n minus 2. And one more thing important, you concentrate on this coefficients also. What is the coefficient of x power n is here? Then what is the coefficient will be here? X power n minus 2 will be here. Then what is the coefficient will be? X power n plus 1. I need all the coefficients will be uniform. Make everything will be uniform. Let us take every coefficient will be x power n. So this coefficient is already x power n, no problem. I want to make x power n minus 2 as n. So that means in place of n, you put n plus 2. So that means it is n minus 2 is here. Then what I am doing? In place of n, you substitute n plus 2. So if it is n plus 2, then what happens? It is already minus 2. Then minus 2, it is only n. Okay, that's why I have written x power n here. So in place of n, n plus 2. In place of n, here is n minus 1 will be there. So I have substituted n plus 2. So that's why I got. Even here also in place of n, n equal to 2. So n equal to 2 is there. Then what I am doing here? I am substituting in place of n, n plus 2. So n plus 2 is equal to 2. That means n is equal to 0. Then again n equal to 0, it is starting. I hope this term will be clear. Now come back to this term. Here it is already x power n is there, don't worry. Then come to x power n plus 1. Now x power n plus 1 must become x power n. Then what I will do here? It is n plus 1. How it will become? Replace n with the n minus 1. If I replace n with n minus 1, it is n minus 1, then plus 1, minus 1 plus 1, 0. It is only x power n. So replace n with the n minus 1. I am replacing n with the n replacing n with the n minus 1. So it is a self-explanatory. So it is equal to replacing with n plus 2. Okay. Then here n replacing with the nothing to do. Here it is perfectly placed. Then here it will be. So n placed with the n minus 1. Okay guys. Then be careful. Here will be the plus symbol. Then here will be the plus symbol. Then here will be the minus symbol. So that is not visible. Then it will be the plus symbol here. And here also plus symbol. Then this here it is only minus symbol. Okay, here it will be the minus symbol. Okay, next simplify yourself, then you will understand everything. Then what I am doing here, I said already, make all the summations will be uniform. So I will make all the summations from n equal to 2 to infinity. So I cannot make here it is with 0. So 2 to infinity I am making. So first thing will be every coefficient of x must be uniform. X power n, x power n, x power n. I can take x power n common. So if I take x power n common, the things will be in here summation starts from 2, here summation starts from 0, here summation starts from 1, here summation starts from 2. You do one thing, you make each and every term summation which starts from n equal to 2. So here no need to change, it is already starting from n equal to 2. So now here it is n equal to 0. First you substitute 0, then substitute 1, then automatically it will become 2. So first I will substitute 0. You substitute here 0 plus 2, 0 plus 1. C2 x power 0. X power 0 will be 1. So that means 2 into 1 is 1 C2. So that means 2 C2. That is here 2 C2. I hope understood everybody. Then what is the next? N equal to 1. Substitute 1 here. 1 plus 2. 1 plus 1. 1 plus 2 will be 3. 1 plus 1 will be 2. 6. 6 C3. And x power 1. Here it is 6. 3 is 3. And x power 1 I have taken common x power 1. Okay, now this term is also over. Come back here. n equal to 1 to infinity. I want to make, so substitute n equal to 1. So 1 into c1 x power 1. See at c1 x power 1. Then 2 automatically common. Then what is there here? N equal to 1. Then you have to substitute n equal to 1. Substitute n equal to 1. C naught into x power 1. See c naught into x power 1. So now understood everybody. Now in every summation sigma 2 to infinity, this term I have written here, n plus 2 n plus 1 I have written here, but don't forget this is n plus 2. Then it will be n plus 1. Okay. So it is a self-explanatory. You take a paper and a pen, you write on a paper, and each and every term you observe clearly. It is a self-explanatory type. You can easily understand yourself. Okay. So after substituting, what I said here, now here it is the term of x power 0 coefficient. This is the x power 0 coefficient. Now this is the term of x power 1. Then this will be x power 2 will be here, x power 3 will be here, x power 4 will be here, depending upon, because n equal to 2 if I put, I said x square, 3, 4 and all these things. What I said now, it is somewhat like a naught. This is a naught. What if this is a1? What if this will be an? This entire thing will be a1. So I got a naught, a1, a2, a3, a4. Then solve this a naught, a1, a2, a3, a4 for c naught, c1, c2, c3. So I said already that equation identity equating the constant term and coefficients of various powers to 0, because right hand side is 0 is there. So in the left hand side each and every term will become 0. If your left hand side each and every term will become 0, what is the first term will be constant term, that is 2c2, it will become 0. Then this entire thing will become 0. So 2c2 will become 0. I have written here 2c2 will become 0, that means c2 will be 0. I got c2. Now next 6c3 plus c1 minus c0 is equal to 0. So already c2 0. So I got it. Then from here c3 will become c3. Keep here, bring that side c0 minus c1 by 6. c3 also I got. Then c4, then c5, then c6. So then last one, what is there here for us? So this entire thing is also 0. This entire thing is also 0. This entire thing is also 0. Make it that entire thing will be 0. Then n into n minus 1 cn plus n plus 2. Then from here I can calculate what is cn plus 2 in terms of cn and cn minus 1. Now you can start any number here. Put 2. N must be greater than 2 obviously. You put 2 here. You put 2, 3 here. You put 4 here. You put 5 here. You put. Suppose if I put 1, what it will become? C3. So it is already here. If I put 2, C4. If I 3, C5. If I 4, 6. So in this manner, I know already C2, C2, C3, C4, C5, C6, everything I will get. Remember, we are getting each and every term in terms of C0 and C1. Okay, I hope it is clear. So this relation generally we call as the recurrence relation. Reoccurrence. That means that means if from here it is Cn plus 2 now. That means if I know C, say for example C2 I know. If I substitute 1 here, I'll get C3. Once I know C3, then I'll put 2 here, I'll get C4. Then if I know C4, then again I will put 1 here, it will say 3 here, it will become C5. Reoccurrence. So recurrence relation means reoccurrence relations. So with the help of recurrence relations, if we know first term, second term, something like that, rest of the terms will be calculated. Okay. So with this, we have calculated the coefficients C0, C1, C2, C3, C4, C5 and 6. And remember, C2, C3, C4, C5 are functions of C0 and C1. Okay. So I put C4, I got C5. So finally what I have to substitute all the C0, C2, C3, C4 values in our assumed differential equation solution. So this is our assumed differential equation solution. That differential equation solution will be this is. Now substitute C0 value, C1 value, C2 value, C3 value. I am substituting here. So once I substitute C0, of course I said already C0 and C1 will be for us unknown. Then C2 can be written as in terms of that. C3 can be written, C4 can be written. So C2 value, C1, C2 value I have substituted here. C3 value I have substituted here. C4 value. So C4 and C2, C4 will become 0. C2 also will become 0 because already I know known for us C2 will be 0. C2 will be 0, C4 will be 0, C6 will be 0. So that means all the power C4 they all become 0. So C0, C1. So finally we left C0 and C1 will be the two unknowns, so you can break them. So if I break them, C0 multiplied by some powers of x and C1 multiplied by some powers of x. Well, so this is the required solution for us near x equal to 0. You can treat this is the solution something like y1. So this is the solution will be y2. So both are independent with each other. We cannot derive from here to here or from here to here. So second order differential equation. Finally, I got the complete solution. The complete solution will be the combination of two functions. One will be of y1 and another will be of y2. So I hope it is very clear. Then again, so we will revise what we did. So what we did with the given differential equation, you put in the form of standard equation and determine p of x and q of x. Check whether they are regular point or not at x is equal to 0. That means whether they are analytic or not. Once they are analytic, and then assume the power series solution y is equal to sigma n equal to 0 x minus x naught whole power n x power n, of course multiplied by cn coefficients will be there. So second derivative determine, first derivative determine, you back substitute into the original differential equation to determine the C0, C1, C2, C3 values. You arrange the terms will be in the simplification. So it is simplification, see it is very problem to problem. It is now, remember one thing, what you need, we need the coefficients of x power 0 that must be equated to 0, then x power 1 that must be equal to 0, x power 2 that must be equal to 0, x power 3, like this. Okay. Now move on to another problem. What is written here, another problem. Find the general solution of, so d square y by dx square plus x minus 3 dy by dx plus y is equal to 0 near x is equal to 2. So here they are clearly mentioning the singular, the ordinary point will be x is equal to 2. We can check whether x equality is an ordinary point or not also. So I said already, you put in the form of standard differential equation. Then luckily they are already given in the standard equation. Derivative of the double derivative, second order derivative coefficient will be 1 here. So now directly p of x will be x minus 3 and q of x will be 1, and I substitute x equal to 2. If I substitute x equal to 2, I am getting minus 1 here. So that means p of x and q of x are not becoming infinite. They will be defined at x is equal to 2. So once they are defined, that means they are analytics. That means it is ordinary point of the given differential equation. Okay. Now what I said, solution. You assume the solution will be in the what form? Sigma n is equal to 0 to infinity Cn into x minus x naught whole power n. What is the x naught value is given here? 2. That's why C0 plus C1 into x minus 2, C2 into x minus 2 whole square, C3 into x minus 3 whole cube, and so on. So about x equal to 2, we are determining the solution. Okay. Differentiating. So first order differentiation we required, second order differentiation we required. Once I know y, once we have taken the y value, sorry. So once we know this y, so we have taken the y. So once we know this y and first derivative of it y dash and the second derivative of it y double dash, then back substitute in the given differential equation, we'll get the coefficients C0, C1, C2, C3 after simple manipulation. So see the what is the manipulation I did here, what is the simplification? It is a simple algebra. I have substituted y double dash term will be here, then x minus 3 multiplied by y dash term plus constant term will be is equal to 0. So this is the differential equation what they have given for us. So in the differential equation, you need to substitute this double derivative x minus 3 into first derivative, then okay, so fine. So I got the double derivative here, this like this like this. Now simplify. Again I said you make first of all the coefficient of x power n. Here obviously x power minus 2 whole power must be x minus 2 whole power n in each and every term. So I am making here x minus 2, that the term will be here x minus 2 whole power n, x minus 2 whole power n, x minus 2 whole power n, x minus 2 whole power n. Each and every coefficient will be, so x minus 2 whole power n has to come. Then what I will do here, what type of things I am doing here. So here x minus 2 whole power n has to come. That means n has to come means n in place of n what I substitute? N plus 2 you substitute. In place of n you substitute n plus 2. That means I am substituting n plus 2 here. Then I am getting. So now similarly here, what is the here? Then like that. You each and every step is clearly written here. You see each and every step, you will understand. Take a pen and paper and make each and every coefficient will be 1. First of all, you multiply like this. X minus 3 is there. You entire thing you multiplied with x. This entire thing multiplied with 3. Similarly, that type of simplifications also you do. So you see that it is a self-explanatory to you. So after all making like this, then what I said here, after making x power minus 2 whole power n, then see that each and everything also will start from some same value, so that I can take the common. Here it is starting from n equal to 0, here it is n equal to 1, here it is n equal to 0, and here it is n equal to 0. So your wish, like make all the things will be some x is equal to all the things will start from n equal to 1, say. So that means here it is n equal to 1 is up, n equal to 0 substitute, then automatically n equal to 1 automatically start the series. If you substitute n equal to 0, then okay, like in this manner. So what I did here, I substituted n equal to 1 and n equal to 0 and n equal to 1. So like this I made a sequence just like before. Okay, so which is an identity equating to 0 the coefficients of various power sum. That means here the constant term, this term will be x power 0 term, x power 0 coefficient will be 0. From here I am determining the C2 value, C1 minus C0 by 2. Then this entire thing will be the 0, this entire thing I will get the recurrence relation. So that is n plus 2 and these all the things. Now from here Cn plus 2 will be is equal to Cn plus 1 minus 1. Okay, so I got the recurrence relation. Once I got the recurrence relation, you can substitute any value here. I can substitute n greater than 1, that must be. Suppose I can substitute 1 also. You can substitute 1, already get C3. C3 will be is equal to C2 minus C1 divided by. So once I know all the C1 values, C2 values, C3 values, so I am knowing all the C, put n equal to 1, that means C3 value I have calculated. Already C1, C2 is known, C3 value calculated. Similarly C4 values I calculated. So C4 value calculated. All this finally we need to substitute in the solution. Y is equal to sigma n equal to 0 to infinity Cn into x minus 2 whole power n. I will substitute C1, C2, C3, C4. Then after substitution, that is C0 plus C1 into x minus 2 whole power 1, then it will be C2 value I am substituting. What is the C2 value? C1 minus C0 by this is. So C0 x power 0, C1 x minus 2 whole power 1, then C2, then C3, then C4 and so on. Then rearrange the terms will be C0 multiplied by something and C1 multiplied by something. So then again I am getting the combination of two solutions. This is the one solution and this will be the another solution. I said already second order DE will have the two solutions, that is two are independent to each other. That means if I say this is Y1, let's say this I say Y2. So the final solution will become Y will be is equal to C0 into Y1 plus C1 into Y2. You observe very clearly Y1 and Y2 are entirely different from each other. We cannot derive Y2 from Y1, or otherwise we cannot derive Y1 from Y2. So that means their ratio will not give you a constant. If I say Y2 by Y1 is equal to not constant, it is not constant, then they are linearly independent functions. Both are different, entirely different. Okay, understood guys? With these two examples we came to know how to determine the power series solution of a given second order PDE about a ordinary point. I hope it is very clear to you. You take any book, so the reference books, it is given in your syllabus copy. You take any book and try to solve. So the methods will be same. Okay, so still further if you have any doubts, so send your doubt. It is very simple. You write your doubt on a paper, take a pic and send to the either mail or otherwise you can send on the WhatsApp also. So for a clarity you can use the app cam scanner, take a pic from the cam scanner clearly and send to me. I'll send the solution to you. Okay, thank you. I hope in our group you can post your questions or your doubts in our group also, so that your doubt may be the doubt of remaining students also, so that everybody will be benefited. Okay, so any discussions will be encouraged in the group. Okay, thank you.